Hello, everyone. Welcome to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University at Albany, and his brother Joel Chaiken to help you figure out how to approach these SAT math problems. So, here's a question of the day. I haven't seen it yet. Seth, I think, has. You have two equations, two unknowns. In the system of equations, A and B are constants. If the system has infinitely many solutions, what is the value of A over B? Oh, it's one of these. The infinite, as he talked about, it's good to think in three modes with the algebra: the table mode, the graphical mode, and the algebraic mode. This is the algebraic mode, but it's also helpful just to remember what it means when you have a system that has infinitely many solutions. It means that the two lines, this is equation 1 and equation 2, they are literally the same equation. When that happens, you get infinitely many solutions. So these guys have to be exactly the same equations, identical equations. Well, wow.
Well, perhaps you shouldn't say identically, you should say equivalent.
Equivalent, fine.
Equivalent means that the equations mean the same thing. More precisely, they have the same solution sets.
Okay. Seth is mathematician, so he talks like that.
The lines are the solution sets of the equations. They are the set of points on the line is the set of pairs of x and y, precisely those that satisfy the equation.
Okay, so let me take a crack at this. I bet you and I are going to do this different ways. So let me take a quick crack at it, and let's see if I get the same answer you do, okay? What I would do is, because I want these equations to be the same, this is the problem, right? You got a problem there with the 12 and the 60. So I'm going to divide this equation by 5, so that at least you get the 12s are the same. So you have ax plus by is equal to 12. I may crash. This may not be the way to do it. And then you have 2/5 x plus 8/5 y is equal to 12. So, doesn't it make sense then that for this case, A would have to be 2/5 and B would have to be 8/5? So then A...
If they were the same equation, yes, A
so
would be 2.
Yeah,
sure.
Chance. So I'm going to take a chance doing this, and I don't know, it'd be interesting to see if Seth would have done it the same way. So I'll take a chance. I'll go 2/5 over 8/5, where now it's helpful to know how to, this is equal to a quarter, but to do it a little slower, you should know how to deal with complex fractions, which are fractions on top of other fractions.
Well,
so
before you learn about fractions, the numerator is 2 piddle poppers, and the denominator is 8 piddle poppers, where a piddle popper is a fifth. And there are 4 times as many in the denominator as in the numerator.
Right.
And therefore it's a quarter.
You have to be really...
There's for each 2 on top, there are... for each 1 on top, there are 4 on the bottom.
Yeah, but as you said, sometimes you say there are coincidences that make things easy. That's not going to help you if you have 2/3 divided by a fifth. Your little logic there about the piddle popper.
Because the top is a piddle popper, and the bottom, the top is 2 piddle poppers, and the bottom is 1 schnuckle.
Fine. But that's a minor point to the problem. That's a minor point of the problem. Many people are not going to see. Don't forget, people are thinking quickly,
I think we beat this one enough.
Yeah, we beat this one enough. Now, so I would say the answer is a quarter. Is that how you would have done it? How would you have done it?
Well, first, the way I saw it, I used like a few semesters ahead of math. And
I can't do that.
What's called the determinants.
No,
affects whether a set of equations has a unique solution or not.
Yeah.
And so, okay, good. The determinant be 0.
Again,
However, the other thing, the other more elementary way is this is a situation, as Joel said, for that is a situation where you want to detect when the two lines are the same line.
Right.
Well, being the same line implies that they have the same slope.
Right, exactly.
And the slope of a line defined by a linear equation is determined by the ratio between the y and the x coefficients with a minus sign, but it's basically the ratio. And so what I did was pick the ratio of a to b to be the same as the ratio of 2 to 8, which is a quarter.
And what about the y-intercept, though?
I didn't do no. I don't do y. I do slopes.
No.
All I did was use the conditions that the slopes of the two lines. That to get the answer, you want the slope of the top line to be equal to the slope of the bottom line. I picked A and B so that the two slopes are equal, and I got it right off.
Okay, but wait. But graphical approach. Here are two lines: black, and purple. Yeah. They have the same slope. They have no solution.
They have no solution, yes. but this is a condition where they have infinitely many solutions,
right, I know.
And therefore they are overlaid, and therefore they do have the same slope.
How do you know they're overlaid?
Because overlaid means that it's given that it says if the system has infinitely many solutions, that implies what Joel said that the two lines are overlaid. That implies that the slopes are equal.
See,
and the slopes are equal implies that 2 is to 8 as A is to B.
I see. So you put some
that's how the logic goes.
So you put some faith in it that I see. See, I'm not the best in English here. Where like I guess I didn't see that they're telling you that these do have infinitely many solutions.
That's what this problem says. The problem gives under the assumption.
Right.
That they have infinitely many solutions. You're asked to reach a conclusion.
Oh, so you trusted them. I didn't.
I trust what if then means.
Oh, okay. I just wanted to really seal the deal.
This is an if-then situation.
I really wanted to seal the deal by ensuring that these guys were also the same.
Yeah.
So it's interesting. We did it both ways.
Since it's an if-then situation, the condition where the if part is false is irrelevant to the question.
I see. Right. Yeah.
So I didn't consider at all the case when there are no solutions.
Okay.
Or one solution.
So I'll tell you, that was a good. Let's do it slowly the way Seth did it. Seth did it by slope. So what's the slope of this one? The slope of this one, you would solve for y in terms of x. So it's 8y is equal to negative 2x plus who cares. So the slope of this one is y.
It's minus a quarter.
Y is equal to minus a quarter.
Yeah.
Minus a quarter. Okay, y is equal to, it's a little messy there. Y is equal to minus a quarter. The slope of here, the slope on this one is the slope is y. We move the ax over. So it's by is equal to negative ax plus junk. So this slope is negative. Wait, hold on. Be patient. The slope here is negative a over b, right?
Right. Okay. So well, kids who took this, who are taking SAT, know a little bit of algebra.
Wait, you're rushing
me. And with a little bit of algebra, you could avoid all that wordy thinking and go much quicker.
Okay, but no, that's you. But you're not. Math geniuses are taking this out. Okay, so I'm just doing it more methodically, right? Doing it by slope. So if I see that y, the slope is negative a quarter. And look at this coincidence. They're actually giving this to you, negative a over b. So negative a over b has to equal negative a quarter, right? Negative a over b has to equal negative a quarter, which means that a over b is a quarter.
Okay.
I know you seem.
But it is. I say if you study for the SAT, it is helpful to learn that the slope of the line that's a solution set to a one linear equation in two one linear equation in two unknowns. The slope is determined by the ratio of the coefficients of x and y. And if you want to determine it exactly, then you might convert it to y equals mx plus b and read off the m.
Right. Yeah, that's what I did.
Yeah.
Yeah.
But the point is that the slope depends on the ratio, and there I didn't say what the ratio is. Did I say the ratio of coefficient of x to y or coefficient of y to x?
No,
and I didn't say on which side of the equal sign the x's and the y's are.
Yeah, so basically.
But for this question, you don't have to go through the extra thought to get it so exactly.
Really? What you mean?
Really, all you have to do is observe that however you formulate the ratio involving A and B, the way you apply it to 2 and 8 is the same as the way you apply it to A and B.
I don't think anyone taking high school math would have the confidence to do that.
Well, maybe if they watch our videos, they will.
No, God forbid they watch our videos.
No, well, yeah, someone watches a video and say, hey, that's easy. I know those crazy guys taught me this trick. When I take the SAT, I'm going to use it.
Frankly, I still don't understand the trick you're using.
Well, sleep over it for a few days.
I'll sleep over it. But I'm not going to start using new fancy tricks on the SAT. I'm going to use tried and true methods. What if
you have 60 seconds left to do 4 problems? What are you going to do?
Hopefully you're not going to be in that situation.
Yeah.
But yes, you had me. But those are going to be the hardest questions because you left those problems off at the end.
Yeah.
Right? If you really do have 60 seconds left to do 4 problems, and those are going to be the hardest problems on the test, I would focus on one of them and just do the easiest of those 4.
What if, wouldn't it be also handy when you see this problem? Wouldn't it be handy if you could solve it in 15 seconds instead of 90 seconds?
It doesn't quite take 90 seconds. Well, first of all, it didn't take me 90 seconds to do the problem cold the way I did it. And probably most people would find the slope a little faster than I would. So what do you say? You're just saying you just divide these two, and that's how you know? I mean, it's not that obvious.
Well, they want the ratio in terms of the particular ratio that they want is A to B.
So okay, if you were really smart, then you would simply go 2 to 8 because you would see the 2 and the 8, and you would use your logic that
that's what I did.
That the coefficients drive the slope. The coefficients drive the slope.
Yeah.
So then you know that these are constants. So if you want to have the same slope, because you were told they have infinite solutions, you don't have to waste the time I wasted on deciding the same line. You simply look at the ratio of 2 to 8, which is 1 to 4, and you do the problem in about 4 or 5 seconds.
Yeah.
Okay.
However, I must confess that when I first saw the problem, I did not make this calculation in terms of a handy formulation of the slope. What I did was jump to what's taught in college math, which is take the determinants, which resulted in some extra calculation.
Stop! Nobody knows anything about determinants yet.
Well, they might.
Okay, fine.
You never know.
You know determinants, you could use determinants, but that's a word we're not going to. Okay. But you see, that's interesting, Seth. See, that's a little bit being a little dishonest of you. When you do the problem, you have to honestly say what you really did first and how you stumbled. Because that's
okay. Well, I lied.
Okay, you lied. So you weren't right. Exactly. This happens all the time. After you digest the problem, you think about it for a while. You come up with really brilliant, smart ways to do it. In fact, the answer sometimes helps you see. Oh, I could have just done that. But that's cheating. That's cheating. That's cheating.
But I think after experiencing this problem, when I saw other problems, I thought more quickly to use a equal slope argument, and I avoided. It took me away from just grabbing at the determinant.
Right. Okay. Yeah.
Which is why you want to study stuff. Yeah. Right.
Right. Absolutely. You should. That's why I'm making a plug for Khan Academy for studying for the SAT. Khan Academy is free. You should do all. Hold on to your seat. About 600 questions in Khan Academy. That will really prepare you, because the more questions you do, as Seth said, the more patterns you see, coincidences, just things, relations, mathematical relations that you become familiar with. And this is a good example of that, right? It's a mathematical relation you should be familiar with. So do as many practice questions as you possibly can, and learn from them. Try to look for, say, oh, what was the key to that problem? Wow, I think we really killed this one to death.
Okay, we did it.
We did enough damage for today. Okay, everyone, take care. Please like us, dislike us, comments, welcome.
Oh, by the way, in this problem, the two lines have negative slope. They're more like this than like that.
Okay, well right. Yeah. And if you have any questions you want us to specifically do, let's say please email us at SAT Math Question of the Day at gmail.com. Okay. Hope to see you tomorrow.